Another way to understand and to compare the stability of planes is to use the root locus view. The root locus view is a complex graph in which we plot the eigenvalues, the complex eigenvalues of each mode. On the real axis here, we will have the stability part of the mode. On the vertical imaginary axis here, we will have the frequency, the vibratory oscillating part of the mode. On the negative values are mean damped mode. Positive values would mean undamped, unstable mode. So the further down the negative values on the real axis, the further the stability and the damping. This mode, for instance, will be heavily damped and it will have high frequency. And these 2 points are correspond to the short period mode. These 2 points, on the other hand, don't have much damping and they are slow, where they don't have a high frequency. These two correspond to the fugue modes. In the lateral direction, we get those 4 points usually. This one is heavily damped. This is the roll damping mode. We have 2 symmetric Dutch roll modes, and we have 1 spiral mode, not damped and non-oscillating here. Let's say we want to compare this to another foil or another planes. So we select, for instance, the asymmetric plane, the one with the modified AG25, and same as before, we define a stability analysis, leaving all the parameters unchanged, same as they were for this very first analysis. We don't need a sequence, same as before. We can put 0 here, store the operating point, and launch the analysis. Let's see. And we can see that we've generated a new set of modes for the second plane, and that they're not that different from the one we generated before, which basically means that the foil has not much influence on the stability behavior in lateral direction nor in longitudinal direction. On the other hand, the mass and the inertia and the geometry will have a greater influence, and we will test that later.